Today's lesson will be about our multiplication properties of exponents again. We'll talk about two more. The first one is called power of power. I just call it the power property. Okay. Now the other one is very similar, but it's just taking the power of a product. So it's just this same property, just applied to a multiplication of several bases. Okay. So example 1, just want you to simplify. So the property is saying that if you have a base with a power, so m has a's power, okay, and that entire base is to 1 power. So notice there's no other base in here. So that's where it gets a power to a power, which is the p. Okay, so then what that operation is that's called multiplication. Okay, so a to the m times p power. So example 1, letter A, says 3 squared to the 4th power. So what that is saying to us, using our property, it's saying 3 squared to the 4th, so 2 times 4 would get us 3 to the 8th. So notice how I took the 2 times the 4 to get 8. And also notice that the base didn't change. The 2 is to that base, so the base is already taken care of with the exponent. So I don't have to change 3 to something else. Now also, once you get here though, remember that 3 is a number that we know, so we can find what 3 to the 8th is actually. So if I plug that into my calculator, I get 6,561. Okay, and that would be my answer. Now the expanded form for that is if I'm using the property expand, okay, if I use the expanded one, that means that I'm writing each of those out, because remember 4, or the power of 4 tells me that there's 4 3 squareds. Okay, just like if I say 3 squared, that means there's 2 3's that are multiplied to each other. So here 3 squared times 3 squared times 3 squared times 3 squared is what they're trying to say to me. So if we use our property from yesterday, these are all like bases. So when I multiply like bases, I add the exponents. So 3 to the 2 plus 2 plus 2 plus 2 power, which is 3 to the 8th. And that gets you the 6,561 that we just found earlier. Okay? Letter B is doing the same thing with your x to the 5th, except x to the 5th to the 10th, you're multiplying the 5 times the 10. That gives you x to the 50th. And that would be your answer. Okay? Expanded form would be saying x to the 5th times 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 x to the 5th. See, there's 10 x to the 5ths, so now you're doing x 5 plus 5 plus 5 plus 5 plus 5 plus 5, 6 plus 5 plus 5 plus 5 plus 5. Okay? So then there are 10 5's up there, so 5 plus 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 5 gives us 50. So I get the same thing. Okay? Now notice the reason why I usually use the property is because a lot less work. But if you don't understand how we're getting that, this is the reason why. It is because of that many. We're using the product property from yesterday to be able to do this. Okay? So, next example. Now we're using the power of a product property, where I notice there are two things inside the parentheses, and this can be more. This is just an example, so they're doing the minimum of 2, but this applies to if you have 3 inside the parentheses, or 10 things inside the parentheses, or 1,000,000 things inside the parentheses. All those things just need to be multiplied to one another for this to be a property. Okay? So here, if I have 2 things or more multiplied to each other inside a parentheses, that it's to a power, then each one of those terms inside the parentheses gets a power. So it's like this m gets distributed to each of the stuff inside. Okay? So they each get an n. Whatever that power is, they're multiplied. So like here, the reason why they're just m is because a and b are both to the first power. So 1 times m is m, 1 times m is m. Okay? So example 2 has, or for letter A, 4a to the 4th b to the 9th times c all squared. So that means I'm going to take each one of these things to the second power, even the number. So if I put that through using my property, 4 to the second, a 4th to the second, and even to do a little bit better job there, and then b to the 9th times 2, and c to the 1 times 2. Okay? So now everything's to the second power, or square or doubled. So a to the 4 times 2 power is 8. B to the 9 times 2 power is 18. And C to the 1 times 2 power is 2. Okay? Now notice the 4 also got a power of 1 to the second power. Okay? That means it's just squared. So 4 squared we actually know. So I'm going to change 4 squared to 16. And I leave everything else that I already just reduced. So this would be simplified. Okay? Now that was using the property. If I do the expanded form, then it looks very similar to what we did yesterday. Okay? So here I have 4a to the 4th b to the 9th c squared. So there's 2 of them. So 4a to the 4th b to the 9th c times 4 a to the 4th b to the 9th c. Okay? So if I'm using the property from yesterday, I'm going to combine the stuff that's like. So like here, notice that 4 and 4 have the same power. So, or same base, so 1 plus 1. A would be 4 plus 4. B would be 9 plus 9. And C would be 1 plus 1. So if I simplify that, then I get 4 squared, a to the 8th, b to the 18th, c squared, and like I said, I know what 4 squared is, so I change that to 16. And that would be the expanded. Notice the same for property and expanded. Now on to letter B. Here I have to the 3rd. So I have negative 2 cubed, or 1 times 3. And then F 2 times 3. G 1 times 3. And H 3 times 3. Okay? Now, negative 2 to the 1/3 is going to be, or 1 times 3 is 3. F is going to be to the 6th. G is going to be to the 3rd. and h is going to be to the 9th, because I just took 2 times 3, 1 times 3, and 3 times 3 to get those numbers. And like I said before, with the 4 squared, I get 16. Negative 2 times to the 3rd power is just negative 2 times negative 2 times negative 2. So if I multiply that out, I get negative 8. Okay? So then expanded form, I do the same thing except negative 2f squared gh cubed times negative 2f squared gh cubed times negative 2f squared gh cubed. Okay? So here I have negative 2, 1, 1, 1. So I have negative 2 to the 1 plus 1 plus 1 plus 1 power. And then f to the 2 plus 2 plus 2 power. I have g to the 1 plus 1 plus 1 power. And I have h to the 3 plus 3 plus 3 power. So that gets me negative 2 to the 3rd, f to the 6, because 2 plus 2 plus 2 is 6, g, 1 plus 1 plus 1 is 3, and h, 3 plus 3 plus 3 is to the 9th. And like I said, negative 2 cubed is negative 8. Okay? So that's the basics. Now I wanted to do one where we're combining all of our thoughts, okay? The 3 properties that we talked about, the product property, power of a power, and the power of the product that I just talked about, okay? So I want to be able to simplify. So just like order of operations, I do the exponents first. So that would be the exponent. None of the other ones have exponents, so you do the product of a power property, or power of a product. So then that means that I'm going to take 5 to the 1 times 2 power, x to the 2 times 2 power, and y to the 1 times 2 power. Okay? Okay? Now I want to simplify those, so 5 squared, x squared, or to the 4th, and y squared. Okay? Now how I do this is I group all my numbers together. So I got 5 squared, which is 25. Okay? I'm just going to write that out. I have 2, and I have 4. Okay? All of which are different bases, so I can't use that power or product property that I used yesterday where I add the exponents because they're not the same. So then now I have x. X has 1 that's to the 4th, 1 that's to the 1st, and then 1 that's another 1 to the 1st. Okay? So I'm going to put all those together. Y is to the 2nd and to the 3rd. Notice where I'm getting them. And here is to the 1st. So I add 1. Okay? Same thing with the x's. I found what those numbers were, and I put them together. Okay? Maybe we should use different. There we go. Like boxes. Okay? And then for the z, notice that the first term doesn't have a z in it, but the second two do. So there's a 1, 1. Okay? So now I'm just going to simplify it. So 25 times 4 is 100, and then 100 times 2 is 200. So that gets me 200. X to the 4 plus 1 power is 6. Y to the 2 plus 3 plus 1 power is 7 or 6. And then z to the 2nd. Okay? So that's my answer. Have fun.